This is a continuation of Blitzer's Introductory Algebra, where we talked about how to solve systems of equations by graphing, and we solved by substitution. Those are two of the methods you could use. Once again, when I say a system of equations, I'm simply talking about two lines or maybe planes or whatever, but in this case there's lines. And so what happens in a system of equation is that you have lines, and lines can intersect at a point, and that would make it have one solution. If the lines are parallel, there would be no solutions, or if the lines overlapped each other, it happens to be the same line, then it can have infinite solutions. And so you can solve it by graphing, where you just simply put the two lines on a graph and find out where they cross. If they do, you can solve by substitution, or in this case, we're going to solve by elimination. Elimination and addition are both used to describe this same process. I typically say elimination rather than addition, but you use both. So here are the steps that we're going to use. Step 2 is not used in the first example, just because I'm trying to simplify the process here that we're going through. And then we'll use it again in the other examples. So basically what's going to happen is that you have these two lines, and the idea is that you can't solve an equation that has two variables. In other words, I can't solve for x or for y using this first equation because I have two variables. I need to only have one variable. So whenever I use substitution, I substituted an expression in for x or for y so that I would end up with just one variable. But by the elimination or addition method, basically what we're going to do is we're going to take the two equations and add them together. Now that seems kind of weird, but I promise it works. I didn't make it up. All right. So I'm going to basically add vertically the x values. I have an x here and another x that would give me two x's. When I add the positive 1y and the negative 1y, I actually get no y's. And then I add the 4 and the 6 and I get 10. Now the advantage of this method is that if you can add the two equations of the two lines together and eliminate one of the variables, now you have an equation with just one variable. Now you can solve for the point in which they intersect if they intersect at a point. So now I can easily solve for x, and I know that x is 5. Okay? So now that I know x is 5, I can back substitute that into either equation. I get to choose. I'm going to choose the first one just because y is positive in this one, meaning there's a positive in front of the y. Okay, now that I know what x and y are, I can write the answer in point format, which means that if I were to graph these two equations, okay, if I were to graph these two lines, they would intersect or cross at the point x5 and y negative 1. So that makes it kind of handy. All right, you try the right one. Okay, now the advantage, like I said, is that we didn't have to do step 2, which is multiplying an equation. We won't do that yet. But you could just add the equations together like they are right away, and one variable is eliminated for you. Okay, so let's do some more examples. Now in this next example, okay, we're going to solve by eliminating. If you notice, if I add the x's together, I'll get 5x. And if I add the negative 1 and the positive 5, I get 4y. And then 24. Well, that doesn't help me at all, because if I add them together, I don't eliminate a variable. I still have x's and y's and the constant. So that's not going to help me. So this is where that step 2 comes into play. Step 2 says that if I take either one of the equations, or both, and multiply it by any number in the whole world, it can be a positive number, it can be a negative number, it can be a fraction, it can be anything that you choose, in such a way that by multiplying the left and the right of an equation by that integer, it causes the addition method to work, in other words, a variable to be eliminated, then I can do that, okay? Just like any equation in the whole world, I can always multiply the left side and the right side by the same number, and I don't change the equality of that equation. I mean, it stays equal. So I have some options here. I'm going to try the first option, where I notice that if I multiplied this first equation by 5, and I would get a -5 here, -5 and +5 added together would eliminate my y's. So I'm going to do that. I'm going to take the first equation and multiply by 5. The left side by 5 and the right side by 5. Now don't forget to multiply the right side by 5. A lot of students forget to do that. They'll get this left side just fine because they won't write this out. They'll just do it in their head and they'll say, oh, I'm just going to multiply it by 5. But then they forget the other part. So make sure you do both sides. So this is the first equation, just rewritten, multiplied by 5. Now I'm going to take the second equation and just write it right below it. Now I'm going to use the addition method. -5y and +5y are eliminated. That's what I wanted. That was my goal. Okay, and so the advantage of that, like I said, is that we are trying to solve. Okay, now that I know x is 4, I can back substitute 4 in this equation for x or in this equation for x. It doesn't really matter. I'm going to choose the second one. Okay, so just doing basic algebra, and we'll notice that the solution to this is 0.41, which means if I were to graph this line and this line on the same graph, they would intersect at the 0.41. Now I just want to show you something not to confuse you, but what if I were to take this and I said, I don't want to solve for the y's, I don't want to eliminate the y terms, I want to eliminate the x terms. Well, there's not anything that I can multiply only one of these equations by to eliminate the x term. So if I were to multiply the first equation by a 2 and the second equation by a -3, I could actually get both of them to be 6 and -6. Okay, so that's just what I'm thinking. Okay, so I'm going to multiply the first equation by 2 and the second equation by -3. Okay, sometimes this happens, like the equation that I gave you right here, it works out that you can just multiply one of the equations and then it instantly, can be added together and eliminate a variable, but that's not always going to happen. Okay, so this equation is 6x Okay, now I'm just going to rewrite this equation over here. Now I'm going to add them together. The x's are eliminated. 39, 22, so... Okay. Okay, now I have y is 1. I can take y is equal to 1 and substitute it into either equation. Notice my answer is the same no matter what, okay? So either method works. Again, this equation you didn't need to use the second method. I was just demonstrating it for you because later you will have systems of equations in which you can't just multiply one of the equations by a number. You're going to actually have to multiply both equations in order to eliminate. So if you do the one on the right, practice 6. Here's what you get. All right. let's do one more. So we're going to solve by elimination. I have the option of multiplying either the y term by something or the x term by something. And so in my opinion, I would probably, since one of these has already been negative and one of these is positive, I would go ahead and eliminate the y term. But I don't want you to get into the habit of thinking that the y term is always what's eliminated. Sometimes the x term can be eliminated as well. So I'm going to multiply the y term by 4, and the reason I'm going to do, or excuse me, the first equation by 4. And the reason that I'm going to do that, like I said, is because it makes the y term, there's already one, there's actually already one that's negative and one that's positive, because when you add together in order to eliminate, one of them has to be positive, one of them has to be negative. So you have 12x, and I don't remember what 48 times 4 is. I know it's 96 times 2, 192. I think that's 192. Okay, and so, all right, and then we have 9x minus 8y is equal to negative 24. So I get 21x is equal to 168. Let me check my math. Just double check. Okay, minus 24, 160. Oh, good, I did it right. Okay. All right, and then divided by 21 is 8. All right, now that I know x is 8, I can plug it into either equation. I'm going to choose the first. Okay, and so the answer to this is 8, 12. That means this is the point which the lines cross. Now, just to show you that if I had chosen to eliminate the x term, I would get the same answer. It really doesn't matter if you eliminate the x term or the y term. These lines cross at a point, and that will never change. Here's the answer to the right side. Now, I just want to point out that if you're using the substitution or the elimination method or addition method, okay, that for infinite solutions, which we didn't talk about except in graphing, infinite solutions, and no solution, this would be where the lines were parallel. What would end up happening with infinite solutions is that when you try to use either one of these methods, you would end up with a true statement, such as 5 is equal to 5, or 1 is equal to 1, or 0 is equal to 0, something that's true all the time. The variables would end up both canceling out exactly, so you wouldn't have that option. For no solution, you would end up with a false statement. In other words, the variables would all cancel out. You wouldn't have the option of a variable, and you would get something like 0 is equal to negative 1, or 0 is equal to 3, or something like that, which is never true. So if you get a true statement and all the variables cancel out, it means that the lines overlap. There's infinite. If you end up using this method and you get a false statement, something that's never true, 0 is never equal to negative 1, 0 is never equal to 3, then that means there's no solution and the lines are parallel. All right, good luck.